Let's look at some examples of graphing inequalities. Example number 1 is x is greater than 2. X is greater than 2. We begin by drawing a number line, and we can choose where to place the numbers on this number line. The boundary number is 2, and so I'm going to place 2 at a convenient spot. I'm going to pick this spot and call that 2. Now this is a little strange. You're accustomed to starting a number line by picking out a place for 0. But 0 is not so important on this graph as 2. 2 is the boundary number, and I must be sure to include it in my picture, and so I'll put 2 down first. Then let's put some other numbers on here. To the right of 2 we have 3, 4, 5, 6, and so on forever. To the left of 2 we have 1, 0, -1, -2, and so on. The procedure says first I must circle the boundary number point on the number line. So I circle the boundary number point, which is 2. Fill in the circle only if the boundary number is included in the solution. Notice that this says x is greater than 2. 2 is not greater than 2, and so I do not include 2 in my solution. Therefore, I do not fill in the boundary number point. Then I must shade all the points on the number line that are included in the solution. I want all the numbers that are greater than 2. So let's try on this side of the number line. 1. 1 is greater than 2? No, that's not true, so I don't include that point. On this side, 3. 3 is greater than 2? Yes, so I must include that point. Numbers to the right of 2 are the numbers that are greater than 2, and so I'll shade in all the numbers that are to the right of 2 going out forever. So here's a picture of x is greater than 2. Do not include 2, but include all the points that are to the right of 2. Our next example is x is less than or equal to 15. What's the boundary number this time? Well, it's 15, so I'm going to pick something convenient and call it 15. And then I'll label some numbers on either side. Going to the right of 15, I have 16 and 17 and so on. To the left of 15, I have 14 and 13 and 12 and so on. 15 is the boundary number, and so I circle that boundary number point. Is 15 included in the solution? It says less than or equal. If I fill in 15, 15 is less than or equal to 15. Yes, 15 is equal to 15, and so it fits the either less than or equal to condition. That means I do fill in 15. Then I choose a point from either side to see which is true. If I try 14, 14 is less than 15, that is true. Numbers to the left of 15 will be included in this graph. And so I shade in all the points that are to the left of 15. 16, if I try 16, 16 is less than or equal to 15. No, it is not. I do not shade in points to the right of 15. Let me show you both graphs to point out a feature of these graphs. In each case, can you tell at a glance what is shaded in and what is not? Look at your own graph. Can you tell on your graph what is shaded in and what is not? Remember the old adage, a picture is worth 1,000 words. These pictures of inequality graphs must be so clear that no one can possibly misunderstand. Be absolutely certain that your picture shows without any doubt what is shaded in and what is not. Let's do example 3, which is x is less than negative 8. X is less than negative 8. The important number now is negative 8, so I'll pick a convenient number and call it negative 8. And then as we go to the right of negative 8 and get greater numbers, we go to negative 7 and negative 6 and negative 5 and so on. To the left of negative 8 we have negative 9 and negative 10 and so on. I'm going to circle the boundary number, which is negative 8. Less than does not include the negative 8 because negative 8 is not less than negative 8, and so I do not fill in the point. Numbers to the left of negative 8, like negative 9. Negative 9 is less than negative 8. That is true, and so I do fill in to the left. To the right I have negative 7. Negative 7 is less than negative 8 is false, and so I do not include the right side. And so the graph of x is less than negative 8 shows all the numbers to the left of negative 8 and a circle on negative 8 itself. Our next example. X is greater than or equal to negative 6. X is greater than or equal to negative 6. The boundary number this time is negative 6, and so I'll pick a convenient number and call it convenient spot and call that the negative 6 point. To the right of negative 6 I have negative 5, negative 4, and so on. To the left I have negative 7, negative 8, negative 9, and so on. We circle the boundary number, which is negative 6. Since negative 6 is greater than or equal to negative 6, satisfying the equal part, we fill in the negative 6. Now we check on either side. Negative 7. Negative 7 is greater than or equal to negative 6. No. Negative 5. Negative 5 is greater than or equal to negative 6. Yes, that is true. And so we shade in to the right. One more example. 4 is greater than x. The boundary number is 4. So I'll pick a convenient number spot and call it 4. To the right of 4 we have 5 and 6 and so on. To the left of 4 we have 3 and 2 and 1 and so on. 4 is the boundary number, so I'll circle it. This says 4 is greater than x, so 4 is not included. That means I do not fill in this circle. Now I'll test a number on either side. We choose 3. Fill in 3 in place of x. We have 4 is greater than 3. 4 is greater than 3 is true. So I fill in the side including 3, which is the left side of this inequality. To the right, 5. 4 is greater than 5. That is false, and so I do not shade in the right side of this inequalities number line. Now, you notice that in example number 5, we had 4 greater than x. 4 is greater than x. Made us shade values that are less than 4. So that means that 4 is greater than x is equivalent to x is less than 4. 4 is greater than x is equivalent to x is less than 4. Notice this graph is the graph of numbers that are less than 4.